In this tutorial, we will introduce the control charts that are used for quality control. Please review the control chart overview tutorial before continuing with this tutorial. Production processes have two types of variation, random and assignable. Random variation is just the natural variation in the output of all processes. Random variation is also known as common variation and inherent variation. Random variation is caused by a wide variety of minor factors. These include human variations, variations in material, machine variations, and so on. Different processes have different amounts of random variation. For example, older machines tend to have more random variation than newer machines, and workers with less experience tend to have more random variation than do workers with more experience. Assignable variation is variation where the cause can be identified. For example, a worn-out drill bit would likely cause a larger variation in the size of the hole it drills than would a new drill bit. While we always have random variation, once the cause of assignable variation is identified, it can be corrected. Assignable variation is also known as non-random variation and special variation. A control chart is a time-ordered plot of sample values such as the sample mean or proportion. You can see that on the slide. As time moves forward, the dots on the chart move to the right. The control chart is used to spot assignable variation. In other words, it helps you distinguish between the uncorrectable random variation and the correctable assignable variation. Control charts use two different types of data, variables and attributes. Variables are data that are measured. Examples include height, weight, volume, and speed. Stated another way, variables are interval or ratio scale data. Attributes are data that are counted. Generally, here we are counting the number of defects. While there are other types, in these tutorials we will see how to create 5 different types of control charts. They are 1. A mean control chart. This is better known as an X-bar chart. We will see 2 different approaches to creating an X-bar chart, one when the standard deviation is known, and the other when the standard deviation is not known and we use the range instead. 2. A range control chart. This is better known as an R chart. 3. A standard deviation control chart. This is better known as an S chart. 4. A proportion control chart. This is better known as a P chart. And 5. A count control chart. This is always just called a C chart. 3 notes are in order. First, the X bar, R, and S charts use variable data while the P and C charts use attribute data. Second, the X bar and R charts are always used together since for things like the diameter of a hole being drilled, it is important to know both the average diameter of the holes and the amount of variation in those diameters. Also note that when the X-bar chart is created using the standard deviation, it would be paired with the standard deviation or S chart rather than an R chart. Third, students often confuse the P chart and C chart. Pay close attention to the explanation in those tutorials about when each is appropriate. There are 2 tables you need for the various control charts. One is the standard normal table, and the other table lists various factors such as A sub 2, B sub 3, B sub 4, D sub 3, and D sub 4. I have not included this table because I do not have the copyright permission to do so. You can easily find a copy online by Googling control chart factors. Before we construct any quality control charts, I need to give you a note of warning about the way these are handled in textbooks. In most textbooks, you are given one set of data to both develop the control limits and to plot the points. Since textbooks want you to have examples of out-of-control charts, they sometimes give you data that reflects this. However, using out-of-control data to develop the control limits means those limits are much wider than they should be. In the real world, you would make sure everything was running perfectly and assign your best operator before collecting the data used to develop the control limits. That would ensure that the limits reflect the best the process is able to do. Then, each new sample would just be plotted on the chart using those existing control limits. Textbooks do not do this because they do not want to develop 2 sets of data for each problem. In this tutorial, we will follow the approach used in textbooks of only using one set of data, but I want you to be aware of the compromise this involves.
If you found that this video helped you with your operations management problem, please consider liking the video and even subscribing to the channel.